About me from your side, something asked?
Yes, I asked you before.
Yeah, I'm really impressed by your submission. It was very good submission, very thorough, very detailed. That's what I want to tell you. So we are talking about thermodynamic equilibrium and the minimization of energy, and what we got that. For two systems, the first system, second system at equilibrium, the three conditions have to be satisfied. P1 equals to P2, P1 equals to P2, V1 equals to U. Temperature of two phases, two systems will be equal. Pressure of two systems will be equal, and chemical potential, or you also say that drift energy, right? Drift energy equal chemical potential, the source of things. So both will be the same in that case. And this criteria has been obtained from this condition grad f x star equals to, right? And what are the independent variables? Independent variables we have seen S, B, and N, S1, B1, and 0. You can write in terms of S1, B1, and 0. And from there you use Taylor series and what. And this says not the minimum or maximum, this says the candidate of minimum or maximum. If you want to talk about the minimum, that is, we will talk about the Hessian matrix and the positive definiteness of the matrix. So always you can talk in terms of, so this equation was based on du equals to pds minus pdv plus mu dv. From here we can write in terms of specific variable, which is du equals to pds minus pdv. Small s. Okay. And for this specific variable, what will be my Hessian matrix? You can volunteer. What will be the Hessian matrix? Any hands, please? Not Rahul. What will be the Hessian matrix? The Hessian matrix is 2 by 2 only, right? Yeah, 2 by 2. Who will give me the Hessian matrix? Who will give me the Hessian matrix? Yes, Devayan. You just say USS. Okay. Okay. USB, UB, okay. So this is the Hessian matrix, and we have already proved the positive definiteness means all the eigenvalues have to be positive. Then the matrix is positive definite. That means chance of minima is there. There is chance of minimum. There is a minimum, not chance of minimum, there is a minimum. So what is my, how to find out eigenvalue? USS minus lambda, USB, UBV minus lambda, determinant equal to 0. Because we know that determinant of A minus lambda I equals to 0. Because A minus lambda I x bar equals to 0, and this x bar is eigenvector. Which space this eigenvector belongs to? We have done mathematical results in chemical engineering. Which null space? Null space. Okay. Determinant of A minus lambda equal to 0. So what did you get? Lambda equals to, you calculate, tell me, lambda. The expression I want. It will be USS plus UBV plus minus D by 2, where D equals to USS minus UBV whole square plus 4. Am I correct? Yes or no? Check it out and then verify. I may be wrong. Is that correct? Yes or no? So this is a simplification. It is not coming directly, but we did some kind of simplification, and based on that you got it. So lambda 1 is USS plus UBB plus root D by 2, and lambda 2 is USS plus UBB minus root D by 2. You have to have lambda 1, lambda 2 both greater than 0 for the minimum. So lambda 1 has to be greater than 0, lambda 2 also has to be greater than 0, right? So this quantity is positive. You have to prove, because USS we found positive. The question is UBB greater than 0? We assume positive. We have to prove it. We have proved this one already. Last class. Dou 2U by dou S1 square. We found, right? Greater than 0. Because it comes with temperature and the CV and all those. So these quantities are assuming positive. This quantity root D, you have to prove that this is real, this is not negative, in that case this is positive. If it is negative, it's a complex. We don't talk for complex. This guy has to be less than this to get positive. Okay? So what's the condition for lambda not greater than 0? Condition for the positive eigenvalues. We have root D should be less than USS plus UBB, right? And we have D less than USS plus UBB whole square. This is USS minus UBB whole square plus 4USB square less than USS plus UBB whole square, because determinant is this one, right? Determinant is given by USS minus UBB whole square plus 4 USB square and this. Just I have copied determinant, nothing else. I have just copied the determinant. What's the final expression then? We get a very cute expression. What is that? You get a very cute expressions. You get a very cute expression. What is that expression? You get a very cute expression. What is that expression? One expression I got. Any other expressions? Any other expressions?
USB less than USS UE.
USB square should be there.
USB square.
Okay. So it is USS. What now will also get UBB minus USB square. You got this, right? We know USS greater than 0. UBB we are yet to prove, or you can prove it. You can prove it. UBB greater than 0. You go home and try to prove it. I'm sure you can prove it. And we don't have to prove this. The question is how to prove it. We are saying that is a condition. Question is it satisfied in thermodynamics? On what condition is satisfied? That's the question comes. We have not proved it. Okay? What is UBB? Dou U by dou B equals to what?
Minus B.
Correct? and UVB is rho 2U by rho B square. Yes, it is what? Minus rho P by rho B. And rho P by rho B, this quantity is what? Negative or positive? Negative always. It cannot be positive. So this is confirmed. This is not, no question mark. This is confirmed. UVB is greater than 0. That part is solved. But this is still unresolved issue. This part is not resolved. How to get it? How to get this part greater than 0? Let's look at it. So to prove this part, we will take the help of Legendre transformation. We have done already. So let's relook the Legendre transformation, what we have learned. We know that du equals to pds minus pdv. When you have dh, it should be equals to, you should not be mugging. It should come from your heart. No. dds plus dv. dA. Just 1% please. Yes, madam. Minus SdV. We should say first this term. Minus PdV. dG equals to minus SdT plus VdT. So easy to remember. It's so easy to remember. So this is my fundamental relationship. This is the combined first and second law thermodynamics what we have learned, and these are also combined first and second law thermodynamics. These are all equivalent, and these have been obtained by Legendre transformation. And this expression says that U equals to U hat SB. Okay, my x1 is S, x2 equals to V. M1 is dou U by dou S V, which is nothing but T, right? Nothing but T. I am just revising what we have done. Equals to dou U by dou S means x1 at x2, right? That means we got M1 as a function of x1, x2. Right? M2, which is dou U, dou V at fixed S, which is equals to minus P, which is dou U, dou x2, x1, which you got M2 hat x1, x2. Yes? Okay. So from here now you can see the functions. H equals to H hat, A equals to A hat, G equals to G hat. H hat, what is that? H equals to H hat. Any hand? First you put a hand and then you just talk, otherwise get confused. Yes, sir. You want to say? X? I am talking in terms of x1, x2. This is okay. x1, x2. It's better on us. Yeah. What is in terms of x and m? Anybody can volunteer? Yes. x1 and m2. A m1 x2, G m1 m2. Those things you have learned earlier. I am just repeating what you have learned. I am not doing any extra here. Okay. Then what we have learned, we wanted to calculate this dC, right? Because we know that C equals to y minus summation I equals to 1 to R mi x. We know that, right? If we have complete linear transformation like this for energy, this I equals to 1 to L. Otherwise I equals to 1 to R for the partial linear transformation. And from there we calculated DC. Right? So for us it's very simple. We have y equals to y hat x1 x2. I am saying this as y equals to y hat x1 x2, and you can write dy as dou y dou x1 x2 dx1 plus dou y dou x2 x1 dx2, and we write this as m1 dx1 plus m2 dx2. And we say that mi, which is nothing but dou y dou xi and xj, where j not equals to y. All those things you have done. I am not saying anything different. I am just repeating whatever you have done in Legendre transformation. For enthalpy, we are changing the second variable. First variable is constant, x1. Second variable we are replacing by m2. x2 is replaced by m2. So, we say here, my slope as C2. Sorry, C is the intercept. C2, which is nothing but second variable, right? Am I correct? This is for enthalpy. For Helmholtz free energy, C1, y minus m1 x1. For Gibbs free energy, that's why I put 1. Very nice way to write, very compact for Gibbs free energy. First we take this one, my enthalpy relationship. Okay? dC2, which is dy minus m2 dx2 minus x2 dm2, equation number 1. We also know, dy is m1 dx1 plus m2 dx2. Just now we have shown. If you combine equation 1 and 2, what you get?
m1 dx1 minus x2
m1 dx1 minus x2 dm2. So dc2. So c2 is a function of one hand, please. Don't drop. One hand.
x1 and m2.
x1 and m2. Excellent. So c2 is c2 hand, x1 and m2. Next. Dou c2 by dou x1 m2 is how much from this expression?
m1.
Dou c2 by dou m2 x1 is how much from this expression? Minus x2. Right? Yes? Okay. If you look at, you have the expression USS, that Hessian matrix as USS minus Hessian matrix as USS UVB minus USB square greater than or equal to 0. What my objective is, why I am doing all those? Can I correlate? I am asking a question. USS into UVB minus USB square with something like HSS or HSV or HBV, because this will be easy to prove positive or negative, right? If I say this is equals to this or this, then my job is done. I have to say this positive. What is HSS? Rho 2h by rho s square, which is nothing but rho. What is rho s rho s? T. Rho T rho s. What is rho s by rho T? We have done it, right? Okay, rho s by rho s at fixed P. This right property. And this is okay. Rho s by rho T at fixed P. Cp by T. That has to be positive. So, very interesting thing. And my objective is, if I can correlate with this or this, then I can easily show. That's why I can exploit Legendre transformation. Correct? So what is this quantity HSS from here? What is my HSS from here? In C2. What is HSS in that C2 X1 M2 all this format? What should I write? Rho 2 C2 by rho x1 square at constant M2. Rho 2 C2 square rho x1 square at constant M2. Okay, correct? This, when you try to prove left hand side, what is the objective left hand side? What you have to get? Left hand side you have to get in terms of y. There is no question of M2. It will be having y, x1 and x2. Then only you can show HSS is equal to those things, right? How to get this in terms of y, x1 and x2? Next step, I will do very slowly here. Rho C2, rho x1 at M2 next step, rho C2 by rho x1 M1 you got here, rho M1 rho x1 M2. You already have M1 as a function of the very beginning. We said x1 x2, very beginning. You can say this as function of x1 x2, very beginning when we started the linear transformation at M2. Apply chain rule of differentiation. That means there will be two terms, right? If I apply the chain rule of differentiation, there will be two terms. What will be those terms? If I apply chain rule of differentiation, we have done chain rule of differentiation earlier, right? So many times. That's the heart of this thermodynamics course. Apply the chain rule of differentiation. Apply chain rule of differentiation. Two terms will be there. So easy. I am not getting a response from the class. So easy. Apply chain rule of differentiation. Madam? Pardon? Rho M1 hat. Rho x1. Then? No, yeah, dx1 and dx1 you are not saying, fine. It is M2. Sorry, it is x2. Sorry. Yeah. Then rho M1 by rho x2 This one is having constant, right? This is my usual chain rule of differentiation. Dou m1 by m1 is what? Dou m1 by dou x1 is what? In terms of y, we cannot use that one. Dou m1 by dou x1 at x2. What you can write? Y equals to, you can write m1 dx1 plus m2 dx2. dy equals to m1 dx1 plus m2 dx2, right? Equation number 1. If you look at equation number 1, it says dy equals to m1 dx1 plus m2 dx2. So m1 is what? Dou y by dou x1, right? What is my m1? m1 is nothing but dou y by dou x1 at xj. So dou y and m1 by dou x1 is dou 2y by dou x1 square, right? Dou 2y by dou x1 square at x2 plus dou m1 hat by dou x2 same way. What it will be? What it will be? What it will be? One hand please. Same way. What it will be? Some second derivative with respect to y. Whatever I do, I should not introduce any legendary variables. It should be in terms of y, x1, x2. Otherwise, I cannot prove. You know my objective. My objective is everything should be in y, x1, and x2. There should not be any m1. There should not be any c1, c2, whatever. Otherwise, I cannot prove it. Yes. What will be this term? One hand, please. One hand, please. Yes. No, I just ask you only this term. Don't complicate things. What is this term? Dou a1 by dou x2. We have done dou a1 by dou x1 is dou 2y by dou x1 square. What is this term? I am asking this term. What is this term? Any hand please? Dou 2y, dou x1, dou x2. That x1. Here we have m2. We have to get rid of m2. These two terms so far okay. We are almost done, 80% done. Last is remaining. M2 you have to get rid of. How to get rid of m2? How to get rid of m2? And you cannot get anything from this expression. Now think about, we have got the tools. Chain rule is not working. Next rule is already there, which is implicit functions here. We have the rules with you, and which is minus dou m2 by dou x1 at x2 by dou m2 by dou x2. Am I correct? So you got dou 2y, dou x1 square, x2, and then dou m2 by dou x2. What is that? Dou m2 is dou y by dou x2. Dou m2 by dou x2 is dou 2y by dou x2 square. Am I correct? Yes? And what's about this one? Dou m2 by dou x1 x2.
Dou x1 by x2. Dou 2y by dou x1.
So what will the final term here? What is the final term? What is the final term? What is the final term? It's very easy. Final term. Nothing is different. I can see it. The final term. Yes, madam. Final term. Everything is there. Dou square y by whole square. That's it. That's it, right? So this is nothing but y is u, x1 is s. So it is uss minus u usb square by ub. Okay? And you can multiply this, divide by ub will be there, and you know that hs is greater than 0. I have just proved this is greater than 0. Okay? So we have seen something nice, that it is said that in order to have thermodynamic equilibrium at minimum energy, internal energy, your second derivative of H with respect to S has to be greater than 0 to have the positive definite criteria. So this HSS greater than 0, this positive definiteness, is called the convexity criteria, right? Is it a convexity criteria? Yes or no? Concavity. Convexity criteria. So we have the convexity criteria for H. So for U we have the convexity criteria, for H we have the convexity criteria. Okay? What will happen? So what we have seen, very interesting. For U, USS, UBV having convexity criteria, that means those second derivatives are positive. H of we have seen. What's about, for example, if somebody wants to say dou 2H by dou P square, what will happen? Will that be positive? We have seen everything. So what we have done so far, let me summarize before proceeding further. We have proved USS greater than 0, UBV greater than 0, HSS greater than 0, and which says USS UBV minus USB greater square greater than 0. Next comes HPP. What is HPP? Dou 2C2 by dou M2 square at constant x1. Am I correct? Yes. So you just want to see whether you can correlate with the original variable y x1 x2. So the same procedure. Next step will be what? Next step will be what? Dou C2 by dou M2. What should I write? Dou C2 by dou M2. We have done minus x2. That means we can write minus dou x2 dou M2 x1. How to get rid of M2? It's very easy. Minus 1 by dou M2 dou x2 at fixed x1. What is that? M2 is what? Dou y by dou x2. Dou M2 by dou x2 is dou 2y by dou x1 dou x2 square. Okay? Minus 1 by dou 2y by dou x1 square. Sorry, dou x2 square. Minus 1, which will be u vv. We prove u vv greater than 0. That means this has concavity criteria. Very interesting. So many interesting things you are getting. We have concavity criteria. Correct? So you have dou 2h by dou p square should be less than 0 in order to get minimum internal energy. Should we start now A series? This series is over. USS over, UVB over, HSS over, HVB. A series means AVB, ATT. You have to find out. So let's start with ATT or AVB. So shall I delete this part? Now everything is quite comfortable. So now we are seeing the objective. What we are planning to do? You have to get the second derivatives and see that how you are examining what is actually happening, convexity and concavity criteria. So for a function, C1 is y minus m1 x2. Right? C1 equals to y minus m1 x2. Okay? dC1 is dy minus m1 dx1 minus x1 dm1. This is m1 dx1 plus m2 dx2 minus m1 dx1 minus x1 dm1, and we get dc c1 equals to c1 hat. What function you get? One hand please.
M2 dx2 minus x1 dx.
No, I want the function. Don't say that. I just want the function. I'm saying the differential. I'm asking the function. A1 x2. Yes, that's the answer. A1 and x2. And from here, this expression, you can get dou c1 by dou x1. Sorry, dou x2 m1, which is m2, and dou c1 by dou m1 x2 equals to minus x1, because this and this is getting cancelled. They have only these two terms remaining. Am I correct so far? You have to get first dou 2 c1 by dou x2 square, and then dou 2 c1 by dou m1 square, right? Dou 2 c1 by dou x2 square, or dou 2 c1 by dou m1 square, right? You have to get what? You have to find out your expression is dA equals to minus S dt minus P dP. It is A is nothing but dV, right? This is your x2. This is your m1, right? Correct? You have to find out A dt, A dV. Okay? So, dou 2 c1 by dou x2 square, which will give you A dV, right? At constant m1. What did you get? I won't tell you anything because we have already done the previous one. From the previous experience, directly you have to tell me. Dou c1 dou x2 you know. Dou c1 by dou x2 is what? Yes or no? Anything you know? m2. Okay. And m2 is the function of? Okay, so what will you get? Use linear transformation and give me the answer. Just like previous one. We have done it previously. Which is dou m2 dou x2 at m1. Now m2, can you write any functions? Dou m2 is what? Dou y by dou x2 at xj. Okay, so I want the final step. We have done the same thing. Last problem. Yes, can you write? Pardon? See, don't do that way. I just want in terms of dou y. Don't do any shortcut. Dou square y by then and then that's all. That's all. Don't try to, don't guess. I'm saying you, please don't. It's not like that. You have done it previous problem, previous first part, previous there are two parts. Please look at. Don't be idle. Don't be lazy. Please look at. It is there the last part. If you want, I can do it, but it is not good for you. I want you to do it. Others you won't learn it. I want you to do it. Others you won't learn it. It is there in your exercise book. Come on. It is dou x2. I don't know why you are struggling so much. Dou y by dou x2 at x1 m1. Correct? Yes. or we can write in terms of M2 dou x2. What is M2 function? What is that? x1 x2. Proceed. This is the best way. Do the chain rule of differentiation. I need not do all those things, is already done. Last problem, but you could not do it. So again I am following it. Okay, no problem. What are the terms? Who can follow? Who can tell me who can volunteer me? Next step. Yes, Devan.
Dou M2 cap hat by
Dou M2 hat, dou x2. Yes, constant.
into dou x1.
No constant here.
Yes, sir.
What constant?
x1.
X1. Then
Dou x1 by dou x2.
dou x2
Sorry, sir. Dou x2 by
at constant m1 plus
dou M2 hat by dou x2. Dou x2.
dou x2.
Yes, sir. Dou x2.
Then
x1 at x1.
I think completely gone. Here. Completely screwed up. So Devan confused me completely. Devan was successful to confuse me. No, this is nothing. X1. Yeah, if you do like this, that's it. I saw this thing, so obvious thing, what I was doing last time, and I have to do it again, I don't know why I'm sweating in the class. Yeah. Maybe I should not be teaching this one, but I feel, as a teacher I should have done it. I'm doing it, but I don't know why I'm doing it. Okay, this is X2, this is X1, this is M1. So simple. I don't have to remember it. Okay? So this dou M2 by dou x1 at x2 is what? So M2 is what? M2 is dou y by dou x2, right? So what will be that? So this will be going as dou 2y by dou x2 square. This will be dou 2y by dou x1 dou x2. Yes or no? You are getting all wrong answers. I am getting all wrong answers from your side. M2 is dou y by dou x2. Dou x1 of M2 is dou 2y by dou x1 dou x2. And this will be done by implicit function theorem. And what is the final answer? I won't write it here. At least you should be doing it. What's the final answer? Dou square y by dou x2 square minus dou 2y by dou x1 dou x2 whole square by dou square y by dou x1 square. Right? And now we can see that this is USS, this is USB, this is UVV. This is already greater than 0 proved in the previous problem because HSS was greater than 0. So what are you getting here? This is what? ABB, right? Am I correct? This is ABB. So ABB is what? Greater than 0, less than 0? ABB greater than 0. So when we prove HPP less than 0, ABB is having convexity category. What will happen ATT? What will happen ATT? So ATT, which is dou 2A by dou T square, which we write dou 2C1 by dou M1 square at constant. At what constant? A what? X2. Okay. What should I write then? Next step, we have done it. Previous problem. We have done the previous problem. Dou C1 by dou M1 is what? What is that? Minus x1. So what will you get? minus dou x1 dou m1 at constant x2. It will be reciprocal of. See, these things will be coming automatically. It is done in the previous problem. You have to just copy from the previous problem. It is so straightforward. You don't have to copy from your friend's notebook. It is there in your own notebook. You are so lazy, you don't even look at your own notebook. It's just there in the previous problem. You do copy madam the previous problem? Yeah, you don't want to see that previous problem, right? You feel so lazy. Your own exercise book. I am not asking you to have that. Anyway, it is your part, not my part. So what's the answer? What's the answer? It is so easy. It's like just 2 steps. It is just 2 steps. It is just 2 steps.
Minus of 1 by cos by u will be
So what should I write? 1 by u.
cos by u.
What should we write?
USS.
USS. So what actually happens? ATT less than 0. So one interesting thing I found, whenever we have got intensive variable, we are getting concavity criteria. B is not intensive variable, it is extensive variable, specific variable. The intensive variable, pressure, temperature, they are the intensive variable, right? So whenever the derivatives are taken with respect to intensive variable, they are having concavity criteria here and here. Whereas we have the specific variables, or the respect to specific variable, second derivative have convexity criteria. Please write down. You won't have any of, you won't get this statement in any of the books available in the market, starting from standard and thing. So with respect to specific variable, the second derivative has convexity criteria. With respect to intensive variable, the second derivative has concavity criteria. The second derivative has concavity criteria. Okay? So with that statement, can you go a bit further? Can you go to the Gibbs penalty and see whether my statement is still valid? That means what? That means if I now look at dg equals to minus sdt plus vdp, which says s equals to s hat t and p, stt and spp. Can you prove it? If you prove it, then my statement is justified. That means I am saying that both these should be less than 0 because my derivative with respect to second derivative with respect to intensive variable. Okay? With that I will end because I have to give you the answer sheet now and we will start on